Okay, welcome. So what we're talking about today are two-way tables. You should have been working on this warm-up as your computer was logging in and going to this video. Now these are actually two-way tables that we're looking at now. Now I'll go more into the formal definition of everything later, but I just wanted you to become familiar with these tables. Kind of look at them, see what's going on here. So we have boys and girls in schools, and then these are the two different schools, Newcastle and Sunderland. All I wanted you to do was fill in the blanks. Okay, so fill in the missing numbers of these rows and columns. So what you want to do is you want to have the total over here. So I just add my rows. How many total students are at Newcastle? 3 plus 12, so that's 15 total here. How many are at this school? 18 plus 6, so that's 24. And now I'm just going to add down. 3 plus 18 is 21. 12 plus 6 is 18. And then just to make sure you're right, if I do 21 plus 18 or 15 plus 24, I should get the same answer, which is 39. So notice, the rows add up to this total, and the columns add up to the totals at the bottom. And then this corner right here, the bottom right, should add up from the totals of the column and the total of the row. So there's table A. Now, table B is a little different because I have different parts missing. Okay, so it's kind of like a puzzle where you got to decide what you can find first. I can't find the big grand total because I don't have any of these numbers. So there's two places you can start. I can find my total number of boys. 3 plus 7 is 10. And now here's where I need to think. Something plus 6 equals 20. So I would do 20 minus 6, and I would get 14. Now it kind of looks like something that we just did in A, where I add my rows. So I would get 17 here, 13 here, and then my grand total would be 30. All right, table C now. Again, you have to decide where to start, because sometimes you can't start where you would want to. First thing I saw, which you can just check your work, because hopefully you have a lot of it done, the boys, 20 plus 10 is 30. Now I have all the girls' information missing, but I have all the totals. So I do my total minus my boys, so 27 minus my 20 is 7. 18 minus 10 gives me 8. I could add 7 and 8 and get 15, or I could do 45 minus 30 and get 15. Last one. The first one I see is, again, this column. 14 minus 8 is 6. I can't find this column yet, but I could do 16 minus 8 and get this number. I could do 6 plus 13 and get 19. 8 plus 13 and get 21. And then these two numbers plus these two numbers both equal 33. Oh, excuse me, not 33, 35. There we go. So again, make sure you have all your answers right, and that was the explanation just in case you needed it. All right, so our next part is our objective. So there's a spot for you to write down your objective, so you can pause this and write down your objective. We're going to learn the properties of two-way tables in order to build tables and answer probability questions. So you just worked with something called two-way tables in your warm-up, and hopefully you became familiar with it, and you're going to work with it even more today. Okay, first we have two-way tables, and we need a definition. All right, the definition of two-way tables, just a formal definition if you looked it up online. It's a table that compares / shows two sets of data at once. That's what's special about it. You see two sets of data at once, and then you can make comparisons. So if you think back from your warm-up, in the columns, it was your gender. So one set is in the rows, and one set is in the columns. Or the columns are the schools. You got it. one set in columns. So we have two sets of data. Again, one is going to be in your rows, one is going to be in your columns. They're going to be different. That's the whole point. We're comparing them. So here's a table that's already filled out for us, and I just kind of wanted to talk about it a little bit. So we're looking at a high school, and it has the grades at the top. So we have 9th, 10th, 11th, and 12th, and then we have males and females. Okay, so now this is saying that 26 of the 9th graders are male. 32 of the 9th graders are female. There are 31 males who are in 11th grade. Okay. The one thing that you need to do with your table, in case it's not there, because it's easier to answer all these questions, is have a total column. So that's what you're going to do right now. Okay, so you need to add that into your total, or add that into your table, and now find the total. So I'll do one for you. For the male, you add 26 plus 58 plus 31 plus 15, and I get 130. So take a second, pause the video, and then fill those in. And you should, now that you're back, you should have these answers. 162, 58, 122, 78, 34, and our total number is 292. Again, that's just us reading it. All right, now we're going to go through 3 different examples so that you can complete your worksheets today. All right, example 1. It says, a statistics class has 15 juniors and 13 seniors in it. 8 of the seniors are females and 7 of the juniors are males. Create a two-way table to represent the information. So there are no numbers now started for you in this table. There's no numbers started for you. So you need to fill in, based on reading the problem, what you know. So I always start at the beginning. I just reread the question again. A statistics class has 15 juniors. Okay, let's stop there. 15 juniors. Does it say whether they're male or female? No. It says total juniors are 15. So I go to juniors, I go to total, 15. My next sentence. 15 juniors and 13 seniors. That's my total number of seniors. My seniors, my total for seniors, I just kind of go together, is going to be 13. Okay, seniors total is right here. My seniors is a column, so my total for that column is at the bottom there. 8 of the seniors are female. Okay, 8 senior females. So senior females, 8. So seniors and females, 8. My next one is 7 junior males. So juniors and males, there are 7. So now you pull down all the information that the problem's going to give you. And now it wants you to fill in the rest of the table, which you can do now. So remember, your columns need to add up to 15. This column, juniors have to add up to 15. Seniors have to add up to 13. And you got to figure out what the rows are going to add up to. So take a second, pause the video, try that out. So here are your answers. We have 8 here, 5, 12, 16, and 28. This is kind of the first part of doing two-way tables, taking out the information of the problem and setting it up into a table. So again, pay particular attention to the language that the problem uses and make sure you're entering it into the right box. Okay, so we're going to do another example. Example 2. At a used bookstore, I spelled book wrong. At a used bookstore sale, there are 120 children's books and 80 adult books available. 50 of the adult books are nonfiction, while 40 of the children's books are nonfiction, while all other books are fiction. Build a two-way table. So I made this one a little harder. The reason it's a little harder is because I did not fill in the actual data at the top of the rows and the columns. Okay, you're going to have to fill that in. Now I'll give you a hint. This one is always total. The bottom row is always total, and the last column is also always total. So now we have to think about the two sets that are getting compared. What are the two things in this problem? The two things, the first set of information is that there's children books and adult books. That's our first set. There's children's books and adults books. So that is what's going to go in our row here. Now, would it have made a difference if I put this in the rows? No. It would not have made a difference if I put it right here and here. It would not have mattered. Would it have made a difference if I put adult first and then children? No. People's tables might look a little different depending on their order, but their totals are going to be the same. That's the most important part. Okay, the next part that we have are what kind of books are they? Well, there's nonfiction and there's fiction books. So this is our set of data. Children and adults, fiction and nonfiction. So that's what we're going to put in our rows now. Fiction. And now we can fill in with numbers. Red. Now we reread the problem again. 120 children's books are available. So 120 children's books. Do I know if they're fiction or nonfiction? No. But I know that the total of children's books, children total, is 120. The next one, 80 adult 80 adult books available. So that means 80 total adult books. So adult total 80. Keep going. 50 of the adult books are nonfiction. Adult nonfiction 50. Next part. 40 of the children's books are nonfiction. 40 children, nonfiction. Children, nonfiction, 40. So that's all the information that I know. So that's enough information to fill in the rest of the table. So pause the video, fill in the rest of the table. Okay, now that we have you've done that, check your answers here. This is 80, 30, 110, 90, and 200. So those are your answers. Now we have a third question. Again, very similar to these two-way tables, but we're also going to be answering questions about the table now, kind of getting to the actual probability of this. So here's our third example. Complete the table for the activities chosen by 74 teenagers on an outing. So that's important. Remember, read the problem. What's it say in it? 74 teenagers went on this trip. Did it tell me whether they were boys or girls? No. Did it tell me whether they were rock climbing or mountain climbing? No. So my total, my grand total, is 74. So now we can fill in the rest. Again, pause the video, try it by yourself, get familiar with it. You're going to have to do it by yourself later. Okay, so here's the table all filled in. Now here's the important part, actually using this table to answer probability questions, to make comparisons, to make observations. So number 1 says, what percent of the students were girls? So what percent of the students were girls? So I have to look. How many girls were there on this trip? Girls total, 27. So it says, what percent of the total were girls? So 27 out of 74. So I'm going to do 27 over 74. Just divide that in your calculator. You're going to get about 0.36, which is 36%. I would like you to write it as a fraction, a decimal, and a percent, all three. So 27 divided by 34, round off to 2 decimal places, and you get 36%. Next one. What percent of students went mountain climbing? So it doesn't say what percent of girls, what percent of boys. It says what percent of students, meaning our total. So our total number of students is 74. How many people went mountain climbing? 25. 25 for our mountain climbing total, 74 for our grand total of people who went on this trip. So 25 over 74. Divide that in your calculator, you get about 0.33, which is 33%. Move this up a little bit. The next part. Now here's where it gets a little trickier. It says, what percent of students were boys who went mountain climbing? Or, excuse me, who went rock climbing. So what percent of students were boys? So how many boys do I have? I have 47 boys. I don't care about the girls at all in this problem. I'm only worried about how many boys went mountain climbing. Well, there was 47 boys total, and how many actually went rock climbing? 42. So it's going to be 42 over 47, which is 0.89 or 89%. Okay, so now what you're going to do is you are going to complete 2 worksheets on this information. You're going to have to turn it in at the end, and we will grade it. And do your best. Look back at your notes for some helpful hints.